In this video, we will solve a 2-unit process degree of freedom problem. This type of problem is where degree of freedom is very important. So if you want, you can pause the video here and attempt the problem. So first, we can do a degree of freedom on a number of things. We could do a degree of freedom on this system where we just focus on this object right here. We could also, so in this case, what we care about is this, this, and this. We ignore all of this. We could also do a degree of freedom on the overall system, so like this. So in this case, what we care about is this, we care about this, we care about what's going in, we care about this, and we ignore the inside terms. We could also do a degree of freedom on this, the mixing point, where we care about this, this, and this. And lastly, we could do a degree of freedom on this right here, where we ignore all of this, and we just care about this, this, and this. Now, when we do a degree of freedom, we want it to equal to 0. So some of these cases we get 0, other cases we don't. So we will, try some stuff out. So first I will do a degree of freedom on number 2. So DOF, so in this case, unknown for 2. We have 4 unknowns, 1, 2, 3, 4. If we just consider this system right here, so that's 4 unknown. And how many balances do we have? We have 2, B and T, so minus 2, and we have no relationship. So this would give us 2. So we can't solve this problem using this to start off with. Now, what if I do an overall system? This whole thing right here. Then maybe we can solve. So DOF, overall. So for the overall system, we have just these 2 because we ignore the inside terms. So we would have 2 unknowns and balances. We still have B and T. So that'd be minus 2 is equal to 0. So in order to solve this problem, we will first do an overall system. And so we will do an overall balance. So let's draw a box. And so what we will care about is this, this, this going in, this going out, and this going out. So let's do it. So the first thing we can say is that we have 200 and we have 20 going in. So 200 plus 20, that's what's going in, is equal to what is going out. So we have 30 going out plus 40 going out plus M3. So by doing this, we would get M3, and M3 is going to equal 150 kilograms per hour. Next, we can calculate X3. So X3 is B. So we could say that 200 times 0.3 plus 20 going in, 20 times 0.1, 20 times 0.1, and that's going to equal, so our M3 was 150. We want to know X3, so X3 plus 40 times 0.7 plus 30 times 0.8. I'm just taking the B component, and by doing this we will get X3, and X3 will equal 0.066667. So now we have X3. And now we can do another degree of freedom. So we got everything we could possibly get from the overall degree of freedom. But since now we know these 2 components, we have 2 unknowns and 2 balances. So now we could do a balance on 2. to get M2 and X2. So we could say that M2 is equal to 40 is going out and M3 is going out. And M3 is 150. So 40 plus 150. So M2 is equal to 190. So let's box in this answer. Next, we're going to get X2. So the exact same idea. But now we know M2, we could say that 190 times X2 is equal to 40 times 0.7 and M3 times X3. So 40 times 0.7 plus M3 was this, so 150 times X3, which was this, 0.066667. And by doing this, we get X2 will equal 0.2. And now we need to solve for these two. We can do a balance on number 1 because we have 2 balances and 2 unknowns. So if you want, you can pause the video here and write down the question because I will scroll down. So to get M1, we would have 200 is equal to 30 plus M1, our 2 outputs. And so we could say that M1 is equal to 170. So now we just need to get X1. So same idea as before, 200 times 0.3 is equal to 30 times 0.8 plus our 170 times X1. And by doing this, we would get X1 is equal to 0.21176. So let's box in this answer. And so if you want to check, what you could do is just try to make sure everything balances out. So you could do 200 times 0.3 is equal to 30 times 0.8 plus what we got for M1 times X1. If it equals it, that's one way to prove it. Also, we could do, I don't know, M1 times X1 plus 20 times 0.1. If that equals M2 times X2, you know, we're just further proving. So just to double check we didn't make any mistakes. Because when I first solved this problem, I actually made a mistake. I had to go back. And that's all you need to do for this problem.